In today's lesson, we're going to look at our last big idea for this unit. We're going to look at parallel lines and how angles can be formed when they are crossed. So the big idea here, to start with, parallel lines are always shown by arrows. So we have an arrow and an arrow. The fact that they're pointing in the same direction means that they're parallel to each other. They never cross. They travel in the exact same direction. Sometimes we'll put the arrows on the ends. Sometimes they'll be in the middle. Sometimes you'll see two arrows to say these two lines are parallel to each other, as opposed to a second pair of lines. And when these two parallel lines are crossed, three important patterns are formed. We're going to look at those patterns today. So pattern number one is called the F pattern. So if I think about the letter F, capital F, okay, I call these things right here the arms. Well, the values underneath them in an F always are the same. So if I know one, I know the other. As long as these two things are parallel. Well, if we look at this diagram right here, we actually have some letter F's. So here's an obvious one, okay, in green here. Here's an F. Here's the angle under the arm. Here's the other angle. That has to also be an A. But not all F's are obvious. Sometimes an F could be backwards. Here's a letter F. Here's the arm and the angle underneath it. Here's the other one. Well, that makes this a D. You can also have weird angles. Okay, ones that don't even look like the letter F. Check out this one. Here's an F that goes this way. It's upside down, right? Where's the arm? Well, here's the arm, and the angle underneath it is letter C. There's the corresponding one, also letter C. And obviously, if we have that one, we also have the backwards one, right? The one that's completely backwards and upside down. There's your arms. Angle B is underneath it, or in this case on top of it, looks like. And here's the corresponding angle, angle B. So our F, which can look like an F, can also be this thing, but upside down, sideways. It can be all kinds of crazy directions. Okay? As long as that you can turn your head or turn the paper and see an F, you know you have angles that are equal to one another. Let's take a look at some examples. Okay, what can I figure out in this diagram here? Well, I know some things from previous, first of all. Let's start with the easy ones. I can find angle A because I have a straight line. So A has to be 180 minus 145, or in other words, 35 degrees. I can find B pretty quickly because what do I know about angles that are across from one another? Well, we said those two things are equal. So B is also 35. I can find that C the same way. C is across from 145. So those ones are old ideas. But if I want to find D, I've got to apply a new idea. So where is D? D is down here. Well, let's take a look at these arms that form the letter F. D is the same as B. The two angles under the arms are equal. Hey, there's D by using an F pattern. Okay, let's try the next picture. What can I figure out? Well, the easy ones first. Here's my straight line. W must be 180 minus 102. It must be 78. Z's pretty nice to find because we see it's across from 102. But to get X and Y, I have to get down to that bottom part of the diagram. How do I get down there? Well, I draw a line that goes this way and makes an upside down F. Y is the same as W. Well, W said it was 78, so Y must be 78. Similarly, it's a F that goes the other direction. That's 102, so is X. Now, that's not the only way you could have got X. If you really wanted to, you could have thought of this as a straight line. That's 180 degrees. So X also could have been 180 minus 72, which, surprise, surprise, 78. Surprise, surprise, is 102. Right? There's lots of ways of getting these things, but somehow, if I need to get an angle far away from previous ones, I probably need to use that F pattern. Okay, let's take a look at the third example of this F pattern idea. A triangle. We know triangles. We've seen triangles before. What can I figure out in this triangle? Well, if I look at this triangle, I see I have an F right there. So 51 and B have to be the same. Similarly, on this side, I got another F pattern. So this missing angle is 72 right here. And if I want to find A, I got to think about triangles. What do I know about triangles? I know that triangles add up to 180. So if I get rid of the two parts I know, the B, which is 51, and the 72, I'll be left with my answer, which is 47. And that gets me A. The other way we could have approached that one, if you actually stop and think about this diagram for a second, is it's not just one triangle. There's actually two triangles. A and 51 and 72 make the big triangle. How do I get A? 180, take away 51 and 72 gives us 47. So I could use the small triangle or the big triangle to do the same problem. Okay, pattern number 2. We call this one the Z pattern. So what does the Z look like? Here's a Z. On a Z, angles that are alternating. So on the inside and the opposite inside are always equal. So the obvious one in our picture, right here, here's a nice beautiful Z. Well, there's A, that also has to be A. Or if we go over to the other side, there's C, and this has to be C. But again, not all Z's are obvious, right? You want to look at some weird ones. Let's get rid of those colors. Here is a weird Z. It's been turned on its side and kind of stretched. That's a D. That's the alternating side. That's a D. And we have this one. An angle here, side here, angle here. So this is D, but it turns out it's also B. So in a way, we can actually relate this angle is the same as this angle, even though they're far away from each other because of alternating angles and Z patterns. I think there are more Z's in this picture. I didn't label all of them. I could find more if we wanted to, just to point out. And we could have a backward Z that goes like this, inside and inside. It's been stretched and flipped. And Z's are kind of the tricky one to find because they don't always look like Z's. They often look like lightning bolts. Let's try a couple, see how this works. Determine the missing angles. Okay, so we'll start with the obvious one. Here's a nice beautiful Z. Y has to be 55 because they're alternating. And the less obvious one, on the opposite side, there's also a Z. And it's a backward Z. X has to be 45. So we don't actually have to do any math in this one. We just have to see things. And that's often trickier than doing math. Yeah, let's try part B here. What can I figure out? Well, these are parallel, and the 140 is separate from all the rest. So if I start drawing lines to finish the Z, I need to do it that way, right? Okay, so that's 140. Where's the other 140? On the opposite side. Which isn't the answer I really want, but I can get Y pretty nicely, because Y is across from 140. And if I know Y, I can get X and Z, because either way they make straight lines, or straight lines. So if I do Z, Z is 180 minus 140, in other words 40, and X has to be the same because it's opposite from Z. I'm going to try the third one here. No numbers at all. How are we going to do this problem? Well, what do I notice? I notice I've got not parallel lines, but equal lines this time. How many equal lines? 3. We said before with isosceles triangle, if you draw lines across from the ones that are equal, those angles have to be equal. So this angle, and this angle, and this angle all must be equal. What do we know about triangles? We know triangles make 180. If there are 3 equal angles in it, I can divide it by 3 and get the size of each angle. What's 60? Well, D is 60. E is 60, and F is 60. How can I get G though? Well, if I take a look, here's our Z. E and G must be the same. So G must also be 60. And that's our Z pattern. Okay, third pattern. We call this the C pattern. And often this one is the trickiest pattern because it's kind of different. So let's look at the letter C. And these are parallel. In a C, we have two angles inside the C. This is the one case where things are not equal, though. The two angles in here are different, but they always add up to our favorite number, 180 degrees. Okay. When I'm looking at a diagram, the same diagram we had before, the most obvious C is over here, and I know that A plus B makes 180. Okay. But C's don't have to be the letter C. They could be like the letter U. Here's a U, which is a C on its side. You turn your head. And here, E plus F have to make 180. Or the weird one, the backwards one. You can find the backwards one over here. And we got C and D. C plus D equal 180. Obviously, there's more. There's one at the bottom, like here. Okay. But the trick with this is you have to know one of the two and use our idea of like a straight line. If I wanted to get D in this case, D would be whatever 180 minus C happened to be. Okay, so we can use that idea we've done before, get rid of what you don't want, and you're left with what you do want. Let's try a couple of these ones. Okay, we take a look at the first one. Anything obvious we can figure out that we already know? Well, Z and 135 are across from each other. So Z has to be 135. That's old math. New math. How do I get X? X is part of a C pattern. So if I know this is 135, I can get X by doing 180, take away the other part of the C. 135, or in other words, 45 degrees. Okay. There's question B here. Anything new or old that I can figure out? What can we figure out? Well, I kind of see the letter F right here lying on its back. Okay, the parts under the F are equal, so D must be 35. Okay. In there's also the letter C. There's a C. So A has to be 180, take away 35, which is 145. Now, if you don't like that idea, think what we just figured out with D. D we said was 35, right? Well, isn't this a straight line being divided into parts? How can I figure that out? Well, I take my straight line, 180, and I subtract the part I already know, D is 35. Well, isn't that the exact same math that we have right here? C's and straight lines kind of go together because they're the same idea, just in a different way of looking at it. Okay, how do we get B though? B is an interesting one. B is part of this triangle. Well, we know things about triangles. If we've got two of the three things, we can figure out the third one because triangles always make 180. So if we subtract the two we already know, we're left with the one we want. Okay, now obviously there's other ways we could figure that out if we wanted to. I could have figured out this missing one right here, which I stop and think about that. Also a triangle. I know 1, 2 of the missing ones. I could figure out the third one. In fact, it's the same math. It gets me 95. And then on top of that, oh, look at this. There's another F. This one and this one have to be the same. So most of the problems we're going to look at, there's more than one way of doing them. You just have to find a way that makes sense in your brain a little bit. What can you see? Yeah, let's try letter C down here. Oh, all kinds of fun parts and pieces in this one. Okay, what can we figure out? What can we figure out? Do I know anything? I see some parallel lines. These arrows are my hints. So if I have arrows, I probably have F's, C's, and Z's. I see a C with the C. I can get C. How do I find out C? The C pattern says they add up to 180. So if I take 180 and subtract 65, I'm left with 115 for C. Now, if I know C, I can get B because I have a straight line right here. B will be 180, take away 115. That's 65, which sounds a lot like the 65 I have down at the bottom. Why does that make sense? Well, there's actually a letter Z there too. Could have used that one. Okay, what else do I notice? I'm just going to write some numbers in our diagram, okay? Just, get rid of that stuff. We know that B is 65. Ah, I see some dashes. What do I know about dashes? I know the things that are across from them are equal to each other. Hey, A has to be 65. Interesting. What else can I figure out? Well, if A is 65, here is another Z, another equal angle, more 65s. And if I know the bottom down here is 65, and I see that I have a triangle, and I know 20 in the top, 65 in the bottom, I can get D by subtracting the two parts I already know, and I get 95. Okay, lots of problem solving in that one, lots of thinking. The math is very simple. We're just doing adding and subtracting with that 180 basically. But I have to be able to see and think about what kind of things do I have, what can I figure out. Sometimes, like in this last one here, you have to find things that aren't labeled. I wasn't asked to find this number, but I needed it in order to figure out the part I really wanted. Okay, that's our last big idea for this unit. We're going to do some problem solving tomorrow, just practicing these things. But we've done all the big ideas. Give this sheet a try. If you're stuck, come see me.